Hi, my name is Dhruv and I'm a tutor at Tutor Here. And this video is to give you an introduction about average speed and average velocity. So let's get started. What we did in the previous video was establish what scalars and vectors are. Scalars are quantities which just have size or just have magnitude, whereas vectors have both size as well as a direction. So what we're going to do now is learn about two new quantities called distance and displacement. And let's see whether one is a vector and one is a scalar. All right. So let's say there are 2 points, okay? Let's say this is the starting point and this is the ending point. Let's call the starting point A and the ending point is B. Now, if I ask you to draw a path between these 2 points, how many paths can you actually draw? And I think the answer to that would be infinite, because you can draw any path between 2 points. This is a path, this blue line that you see, this green line is a path. I can draw a path like this. This is also a path. Okay, so what I'm trying to tell you is that there are infinite paths that you can draw between 2 points. All right. Now, if I ask you what is the shortest path between these 2 points, and you would answer that it is the green line right here. All right. What is the shortest path called? This shortest path is called displacement. Okay. So the shortest path is called the displacement. Any other path that you can draw, like this path in blue, or this path that I drew as an example, this red one right here, this is called distance. So the shortest path is called displacement, and any path that you can draw is called distance. So displacement is something that is going to have both direction and magnitude. Now, why would it have direction? Just think about it. If you're at point A and you have to travel to point B, and I say you have to travel along the displacement, you always know that you need to travel in this direction, that you need to travel in this path. Okay, so you have a specific direction for traveling from point A to B. Now, when it comes to distance, there's nothing like that. You can make this distance from anywhere. This blue line is the distance, the red line is the distance. You can actually travel backwards and come towards the front and again take a U-turn. This is also a distance. So distance does not have direction. It only has magnitude. This distance might be 10 meters. This one might be 20. The other one might be 5. You just don't know. So distance just has size or magnitude. It does not have direction. So let's go ahead. Okay, so let's see this scary looking formula right here. Let me change the color. I'm a little tired of red. Okay, let's go to green. Do you see this bar that you see over this V? So this V that is there, it has a bar on top of it. This bar recognizes that this quantity that this variable is representing is not just any quantity, it's a vector quantity, means that it has direction. All right. So this term is called average velocity. Okay. That V with the bar on top is called average velocity. If you remember from our previous video, we did an example about velocity. All right. Now, what is this delta X? Okay. This delta X is saying that I'm displacement. Remember displacement, we just studied it a moment ago. And delta time is called change in time. Now you might be wondering, what is this symbol? This symbol, this triangle, what is this? Why is this shown over here? This symbol is called delta and it's a Greek word, all right? This means change in. So if delta means change in, what does it apply to? It applies to time. So it means change in time, all right? So this is our average velocity. Now, what we did in the previous video was also average speed. So speed is presented with an S. Okay, remember, I will not draw a bar on top because it's a scalar quantity. All right. So speed is distance. Let me write that by D. Distance divided by delta time. All right. Delta time means change in time. So speed is a scalar quantity, which is distance divided by change in time, and velocity is displacement divided by change in time. All clear? Let's go ahead and solve an example now. Okay, so let's read the question. This is one of my favorite questions for people who are just starting out with speed and velocity. So, a donkey runs 25 meters east to eat a juicy pineapple. This is a donkey, believe it or not. I'm sorry if my drawing is bad. All right, so this guy is going to travel 25 meters east. Let's say his starting position is A, okay? His ending position, let's say, is B. And let's draw a pineapple here. All right, this is my pineapple, all right? So this is 25 meters because the donkey is traveling 25 meters east. All right. He then remembers that while on his way to eat the pineapple, he saw an almond. So he also saw an almond on the road. This is a very hungry donkey. He then runs west 10 meters to eat that almond. So let's say he came to B, all right? He came to B, and what did he do? He traveled 10 meters west, traveled 10 meters west to eat that almond. Let me just draw an almond. So this thing right here is an almond, all right? Let me just put an arrow so that's clear. That's an almond. And how much did he travel? He traveled 10 meters west. Now, before we go any further, let me tell you one more interesting property about displacement and distance, all right? So distance is measured in positive values. You can never have a negative distance, all right? See this condition over here, which is assume east is negative and, east is positive and west is negative. That applies for displacement because displacement can be either positive or negative. So he's saying that if you want to count displacement, so from A to B, since it is east, I will assume this is positive 25 meters. But then if it's west from point B to point C, that will be negative 10 meters because the condition is saying that west side is negative, all right? Let's go ahead and read the question. The total time taken by the donkey for his entire journey was 120 seconds. So delta t right here would be 120 seconds. Delta t, 120 seconds. What was the donkey's average velocity and average speed during this time? Okay, let me change the color and let's go ahead and calculate it. So first let's calculate the speed, which is the distance upon change in time. So the distance, like I said, would be added here. So he travels from point A to B, which is 25 meters. And then you add what more distance did he travel? He traveled from B to C, which is 10 meters. And you divide this by the change in time, which is 120 seconds. So let's actually calculate this thing. 0.29 meters, all right, because it's in meters per second. So the speed is 0.29 meters per second, all right? Now let's calculate the displacement. So displacement, let's calculate the velocity. So velocity is the displacement. Now, how would you calculate the displacement? He's saying assume east is positive. So positive 25 meters. So it'll be positive 25, all right? He's saying west is negative, so it'll be negative 10. Negative 10, okay, divided by 120 again. Okay, so let's do this in the rough again. So it'll be 120 in the denominator, and numerator we had 25 minus 10, which was 15. Again, divide, you know what, 15 is a multiple of 120, right? Let's just divide the numerator and denominator by 15. We 1 upon 8. And 1 upon 8, if I'm not mistaken, is 0.125. So your velocity, average velocity, is 0.125 meters per second, all right? And since this is positive, it's towards the east, okay? So what did this guy do, this donkey? He came to point B, he went back to point C, but A to C is still towards the east, right? So you have a positive velocity, all right? So keep that in mind. We have a positive velocity and speed will always stay positive, all right? No matter what. So just to give you a complete recap, we did average speed, average velocity. We studied about distance and displacement. We got to know that speed is always going to be positive and distance is always taken as positive. Whereas displacement, you can have positive and negative. And since displacement is both positive and negative, you also get positive and negative velocities, all right? Velocity and displacement is a vector and speed and distance are scalars. So thank you so much for watching this video. If you have any questions, please leave them in the comment section below. And I hope to see you next time. Thank you.